I'd like you to do one more thing for me on the last two homework assignments. Homework it's it's just an alternative way of doing it besides doing the descriptive statistics that I had you do using the table, which is perfectly fine. I wanted you to see an extra Excel function that can accomplish the same thing. So let's do this part first, which is you already have that done from the last video. And you also did this and this, which gives you your 95% confidence interval. So you can get the same answer by using this Excel function t.inv.2t, which means two-tailed test. So it's called a t-distribution. And so if you use that function and you put in 0.05, which is 1 minus the 95%, so out of 100% of the data points, we're looking at a level of significance of 5%. And then you put in 1 minus the number of observations, which we had 50, so that'd be 49 degrees of freedom is what that means. So when you do that, you get this t-stat here. And then you can use that, if you multiply this number right here by the standard error, you get the same confidence level. So if you multiply the two of those pieces together, you get this exact same answer. So just wanted you to see where that was coming from. This is a really powerful tool. We used to have to do them all by hand like this and get those numbers, and there's quite a bit of math behind that. So I wanted you to see that. And then you can also do that with this proportion statistic. So I didn't have you do that. For this example, I only had you do this, which is fine. I'd really just like you to do this and also this. I wanted to show you this as well. So for that proportion, because that's a sample as well based on the sample, we'd want to have a confidence interval in that one as well. So for that, we use the traditional 95%, so standard deviation based on 1.96 for a 95% confidence interval. So we don't have to generate this t-stat. We just use the 1.96, which is the standard 5% confidence interval when you're looking at a population. Okay, so I'm not going to adjust that. When you take that, it's the standard error, same as we did before. And then you add that, subtract that, so this is the subtract, from the p-value. Subtract that 13.5.6, and then add it. That's going to be your confidence interval. So 95% of the time, you would expect this proportion to be between 46% and 74%. You'd expect that value. So I just wanted to show you those. Let me go to the next one. So I'll have you do this Excel function data. So the reason why we couldn't use this over here for this one is it's qualitative data. Yes, no, right? It's binomial too. It's qualitative data. Over here, quantitative data. So we can use this t-distribution function. So here we go. This is what we're adding in this video. So using Excel t.inv.2t for two-tailed test, putting that in, it's 0.05 again because it's 95% confidence interval, so we have a level of significance of 5%. The sample size was 40, so we used 39, so 40 minus 1 degree of freedom is 39 degrees of freedom. So you get that, and then you multiply that times the standard error, and that gives you the confidence interval. So it's the same thing you get from Excel. And then one more time over here. So it's t.inv.2t at a 5% significant level. Again, 40 data points, so 40 minus 1 is 39 degrees of freedom. And then you multiply that times the standard error, and that's where that confidence interval is coming from. So if you could please add these to your homework assignment for this problem, and also add this one here. And if you could also do these for me. Do these over here, you need that piece, which you did in exercise 6.3. Okay, going to need that piece from 6th Street, and you're going to need this piece, 0.6, from 6.2. Okay, so you need that, you'll need that to be able to run this out. So I hope you can work your way through that. And a little bit of add on there, but I wanted you to see it so that you could see where this confidence level is coming from. Okay.